Now let's think of this question. Two incandescent light bulbs of 40 watt and 60 watt ratings are connected in series across the mains. Then, okay, basically lamps questions normally they'll give in ESE. Okay, preferably like they are yet to give in GATE exam because it's small things only. But anyway, like 40 watt bulb, 60 watt bulb. Okay, lamp. Basically, if you connect a lamp to a source, voltage source, okay, means how lamp work, incandescent lamp work. Okay, let me tell you here, for example, if it is the metal, okay, if I keep on heat the metal, then what will happen in the blacksmith, you might have seen metal will go to red hot condition. Okay, so red hot condition will be there. And if I even at red hot condition also, because at red hot condition only our blacksmith will keep on hammer in order to get the required shape, okay, with the iron and all. Now for example, if you still increase the temperature, if you still heat beyond red heat condition, it will go to white hot condition. At white hot condition, metal will emanate the light. Okay, then like why our Edison in inventing that in this incandescent lamp, why he failed 10,000 times or 1,000 times, some people say. Okay, because any metal, the moment it go to the level of white hot condition, because of the around oxygen, that metal used to be oxidized, in the sense that metal vaporizes. Okay, so that's why our Edison failed those many times. Okay, so even at white hot condition also, metal should not get oxidized. Means that they have taken tungsten, carbon, some things are there. Means compared to electrical engineers, mechanical engineers know about it very well, about the temperature and all. But anyway, the thing is very simple. Means here in the lamp, tungsten filament will be there. Okay, so the tungsten filament will absorb the electrical power. That electrical power will be converted into heat energy. Okay, that heat energy will make this particular filament, tungsten filament, to white hot condition. In white hot condition means my incandescent lamp will give the output of light energy. Okay, now means that what is it, incandescent lamp? It's a pure resistance. Okay, resistance only will absorb electrical power. Resistor will absorb electrical power, it will convert into heat energy, I know. Okay, so it is simply a resistance, we can say. Now power absorbed by electrical resistance, okay, resistor at least in the filament, power absorbed will be electrical power which will be converted into heat energy. So for example, if I think of this resistance is R, how much is the power absorbed by the lamp? Lamp is going to be V square by R. Okay, now means capacity, wattage capacity, if it is more, means that resistance should be less. That's it. Okay, for example, 40 watt lamp is there, 60 watt lamp is there. Definitely for 40 watt lamp, resistance will be more because voltage will be same. Okay, means if I take two incandescent lamps, maybe if it is designed for 230 volts, it also would be designed for 230 volts. Okay, so means for a given voltage, power rating of the lamp should be more, means that resistance should be less. Okay, means that resistance of 60 watt should be less compared to resistance of 40 watt. That is the conclusion. Okay, now if I think of, they are connected in series now. Okay, so previously it is rated for 40 watts. Once it is connected in series, capacity will be reduced and all. Okay, it is rated 40 watt, it is rated 60 watt. Once the lamp is connected across across the given rated voltage. Okay, now the moment they are connected in series, current will be same only. Now for the same current, if this resistance is less here, resistance is more here. Okay, because 40 watt lamp resistance is more. So for a given current, resistance is more, means that power absorbed by this is more. Electrical power absorbed is more, means that light energy liberated will be more. Okay, so 40 watt bulb glows brighter is right answer. Okay.